So let's take a look at APIs and more specifically REST APIs. Don't worry if that makes no sense just yet. We're going to learn about it now. So an API, or an application programming interface, is really it's kind of a way that two bits of software can talk to each other, or two bits of hardware that are running certain software can talk to each other. It's the way that kind of applications interface with each other. I know that might seem obvious now that you know what it means, but that's basically what it does. So in order to understand exactly how APIs kind of work, we need to have a bit of background knowledge of how the internet first works. So the internet is basically a huge network. It's a bit like your office network or your home Wi-Fi network, but just on a huge, huge scale. Where you might be connected to a local area network, the internet is a wide area network. It's essentially the same thing. And it's made up of two major components. We have clients and servers. There is a little bit more to it than that, but essentially we've got clients and servers. Clients are kind of web browsers normally. So if you are surfing the web on your mobile phone, the client could be your phone. It could be the Instagram app, for example. It could be whatever it is that's kind of connecting to the internet. And then on the other side of it, we've got servers. And these are kind of the screenless, kind of faceless computers that sit in data centers normally, that kind of do all of the number crunching, hold all of the files, and then send those to the clients so that we can get a good web experience, be it on Facebook or Instagram or on this course that you're watching right now. So what happens is a client, a web browser, might say, hey, I want the Google homepage. I want to go to https://www.google.co.uk or google.com, wherever you are in the world. Yeah, this goes via something called a domain name server, but essentially it goes to Google's servers that are in a data center somewhere, hopefully near the city that you're in. This web server then sends all of the HTML, the CSS, the JavaScript, any images and cookies and stuff back to the client to display to you as the user. It may also send kind of other data, such as JSON data, but we'll get into that in a bit when we actually start calling some APIs. So let's take a quick look at kind of an example of a web page. So you've got, the simple web pages, maybe a news article or something, might just be HTML and CSS. That's brilliant. We can just go straight to our web server and we can kind of request that web page, we can read it, and then we can go on to somewhere else, on the rest of the internet. What if you've got something a little bit more complex? Such as here, this is actually called Momentum, I think, and it's kind of like a browser extension, which is essentially just a web page that kind of welcomes you to your day's internet use. And actually, this looks like a really simple little web page, but it is actually quite complex and quite dynamic. So if we look around this, we've got kind of at the bottom, we've got this inspirational quote that needs to come from somewhere. We've got a current weather forecast and also a detailed weather forecast as well. We can do web search directly from this page. This, whilst you probably can't see from the image here, that image does actually change daily to just kind of an inspirational or nice image. And there's also a to-do app in the bottom there. Now, something that's quite important about this Momentum app is that we can't just do kind of weather forecasting and have the current weather in our machines. That needs to come from a server somewhere. Additionally, with the image of the day, those images need to be stored somewhere and a decision needs to be made of which image we're going to get. Same with the to-do app. That needs saving somewhere. And with the inspirational quotes, people are coming up with quotes all the time. So we need a database that's kind of constantly updating that. So whilst, yes, our client is going to go and get that web page, our Momentum kind of page from a web server, what we'd need to do in that kind of old style of internet like we've just seen is, well, there would need to be a quotes app on there, and maybe JavaScript is the best kind of language to write that in. We've got a to-do app, and we've decided to write that in Python. The current weather, a forecasting app, that might be in C++ because it's really number crunching and data heavy. We've also got an image server and our web server just to get that that image and that web page back to the client. Well, pretty soon you're going to end up with an overloaded server, or you're going to have to buy so much hardware to run all of this software just to deliver this one web page. Not to mention that if it was just you yourself that was tasked with building all of these apps into your web page, well, you're going to get pretty tired as well. It's going to be pretty mind-blowing for you. So how do we solve this problem, or how do we make it so that we can bring our nice, fully featured Momentum web page to market quicker? Well, what we can do is we can use third-party services. We can use third-party APIs. Now, yes, we need to still have a web server that will deliver those kind of the HTML, the CSS, and the JavaScript to our client. But the weather forecasting app, well, I mean, that will take a team of scientists quite a long time to build. The to-do app, yes, we could probably throw that together, but maybe we want something that's a little bit more robust and easier to use. And we'll need a lot of storage for our images. So what we can do is we can go to companies that have already done this for us. So what we basically say is, this web page that we're giving our users, that's kind of our problem, or your problem as a developer. All of this other stuff kind of isn't your problem. Sort of. So with, for example, the Open Weather application for the current weather and the weather forecasting, we kind of don't care what kind of databases, what languages they're using to write their software. We don't really care what that is. It doesn't matter to us. We just want to hand kind of maybe a latitude and longitude, or a location of where we want the weather for, and maybe some unit data. Maybe we want to say we want it in Celsius rather than Fahrenheit, or something like that. And we just want to get that data back from OpenWeather. We really don't care how they're doing that. We just want that data. What that means is it's kind of not your problem. It's kind of not your problem how all of that software runs. I say it's not your problem, kind of. Unfortunately, all of these companies do come with a bit of an overhead, in that they will have certain rules that you need to abide by. It's not like we can just do what we like. So if we ask OpenWeather for a latitude and a longitude that doesn't exist, well, they're just not going to return us the right data. If we maybe put the wrong password in or something like that. It's important to note as well that very few APIs are free to use, or completely free to use anyway, because there's a lot of time and effort goes into building this software, and those developers all need to be paid, and the servers that they run on all cost money. So whilst lots of APIs do have free tiers, normally that's just enough to get kind of your software working. But if you wanted to actually use it and put it out into the real world with real users, then you probably need to start paying them for using their software. So when we talk about rules, is there a standardized way that we can actually kind of talk to all of these bits of software? Well, thankfully, yes, there is. What we're going to be looking at in this unit is something called a REST API. And REST just stands for Representational State Transfer. Don't worry about memorizing what that means, but that is what it means. There's also a type of API called GraphQL. That's becoming more common, and we'll look at that further on in the course. It's just a slightly different way of requesting the data that you want and the way that you kind of receive that back in terms of its structure. There is also an API style called SOAP, S-O-A-P. And unless you're doing something with the UK train systems, it's unlikely that you'll ever come across a SOAP API. They are a bit of a nightmare to work with, and they are becoming kind of out of fashion now. Maybe if I was setting up an API for a cleaning company, I might use a SOAP API, but that's purely for the irony and the funny name rather than it being actually useful. So what is a REST API? Let's look at the definitions of these. So REST or representational state transfer is an architectural style or a set of rules and constraints that guide how the web should be built. So they're just kind of the guidebook and the rule book that say this is how requests should happen across the web, how that information should travel between clients and servers on the web. You might also see when you're Googling, something called a RESTful API. And all this is an application programming interface, or an API, that actually conforms to the rules and constraints of REST. So you've got REST, which is the rule book, and then if an API conforms to those rules, it is a RESTful API. It's just important to get the terminology right so that you know kind of when you're asking questions, you kind of know what you're asking for. So a REST API or a RESTful API has three major components. First of all, we have the client. And we all know what the client is. It's our browser or our phone or our app. It could be the Netflix app on our computer, for example. We also then have the server, which is going to serve up all of our movies, images, whatever that is. So our clients will make a request to a server. So in this instance, it wants to get a movie. It wants to get a film from Netflix. And then the server will go and get the third important part of a REST API. It will go and get the resource. Now, a resource can be anything, really. It could be images, it could be lists of users, it could be just one user, it could be all of the details about that user. It could be short clips, it could be audio files, for example, in the case of maybe Spotify or something like that, or Apple Music. We would have one major resource that they'll deal with is audio files. So once the client has asked the server for a resource, the server will then respond to the client, hopefully with that resource. In this instance, okay, maybe it's not found. So actually, this is a good example of, 404 not found. If you spent any time on the internet, you will have probably come across, when you've clicked on a link to maybe an article or a web page or a help page somewhere, and it's come back and it said 404 not found. Well, 404 is just a HTTP response code that this is part of that kind of standard way that the internet works. It's important to know, though, that a client doesn't just have to be an app or a phone or a computer. A client can also be another server. So this server could also be requesting things from other servers as well. So I mentioned there a little bit about response codes, and we looked at this 404. Well, there's loads of response codes that we can get, and we'll have a much deeper look at this actually in the next lesson. But some of the ones that you may have come across. So basically, if you request a web page or something, a resource from a server, and all goes well, you've got the thing that you want, you will get a 200 OK. Yep, everything went smoothly, 200. If you asked for a resource, but maybe that resource doesn't exist, you'll then get a 404. 404 not found. An example, actually, maybe think back to a time where you've clicked on a link to somewhere that you need to be logged in for. Now, that page you need to be logged in to view, but you are not logged in yet. Well, you probably got a 401 unauthorized. So these are just a few of the response codes that you can get on the internet, but we'll go much deeper into what each of the response codes are. So we've talked about the responses. What about when we actually want to request things from a server? And we have something called HTTP verbs. Now, don't worry about memorizing these just yet. You're going to get really used to these. And the purpose of this is just so that you become a little bit more familiar with the terminology that we're going to be using. So one of the things that we can do, one of the verbs that we can use is we can get. So we can send a request to a server using the HTTP verb get. And the word get is used to retrieve or read something from the backend. Notice I have put some of these in bold as well. That we'll come to later. So we get something to retrieve or read something from a database or from a backend server. We also have post. So the way I think about this is like putting a letter in the post. You know, if you're using the Royal Mail or DHL or USPS or something like that, we're posting something to our server or to our database. And usually this is used to create something new, to create a new resource. Maybe if you sign up for a new website or something, your browser will make a post request to say, hey, go and create this new user. We also have something called patch, and this is normally used to update something. So for example, if you've created your new user using a post request, and then later down the line you realize, oh, actually we need to update what their last name is. Well, you can use a patch request to update something. And it's important to note that a patch request is normally when you say, we're going to keep all of the data the same, except we're going to just change this one bit. It's almost like you've got a pair of trousers and you're just putting a patch over one part of it. Put is a little bit like updating with patch, but normally you'd use it to kind of replace the whole thing. It's like we're saying that we've got our pair of trousers and we're going to replace them with an identical or slightly different pair of trousers, if that kind of works as an analogy. These things aren't set in stone. You might see puts used just to make small updates, and you might see patches to replace entire resources. But this is kind of the proper way of doing it if you were to follow the rules by the letter. And we also have delete, and I don't think I need to explain this one. Yeah, it's to delete resources. There are some other HTTP verbs which we will touch on later on, but these are the main ones, and I just want to get you a little bit more familiar with the terms. Now you'll notice that I made some of those words bold. And we had the word create, we had the word read, we had the word update, and we also have delete. Now these make up kind of the foundation of database operations. So if you've got an app that can create resources, read updates, update resources, and delete resources, you have what's called a CRUD app. And don't worry, if anyone says that you've got a CRUD app, they don't mean that it's rubbish. They just mean that it can do all of the creation, reading, updating, and deleting of resources. Now, don't worry too much if not all of that information has gone in yet. I just hope that when we actually look at doing the API calls, these things become a little bit more familiar to you than us just kind of throwing these words at you in the moment. Okay, next up, let's actually go and make some API calls.